The engine is the main power-producing component of a car that converts fuel into mechanical energy. Its origins trace back to the late 19th century when inventors such as Carl Benz and Nikolaus Otto developed the first internal combustion engines for automobiles. What makes the engine unique is its ability to ignite a controlled mixture of fuel and air inside cylinders, creating small explosions that move pistons and turn the crankshaft. This process ultimately powers the vehicle's wheels. Engines matter because they determine a car's performance, efficiency, and overall driving character. Transmission. The transmission is the system that transfers power from the engine to the wheels while adjusting the gear ratio. Early transmissions appeared soon after the first automobiles when engineers realized engines needed mechanical assistance to operate efficiently at different speeds. What makes the transmission distinct is its use of gears that multiply or reduce engine power depending on driving conditions. It allows cars to accelerate smoothly, climb hills, and maintain speed without overworking the engine. Because of this, the transmission is essential for both performance and fuel efficiency. Radiator. The radiator is a cooling device that prevents the engine from overheating during operation. Its development came alongside early combustion engines, which produced large amounts of heat that needed to be controlled. What makes the radiator different is its network of thin metal tubes and fins that circulate coolant and release heat into the air as the car moves. This constant heat exchange keeps engine temperatures stable. The radiator matters because excessive heat can quickly damage internal engine components. Alternator. The alternator is a generator that produces electricity for the vehicle while the engine is running. It evolved from earlier automotive generators used in cars during the early 20th century. What makes the alternator unique is its ability to convert mechanical rotation from the engine into electrical power through electromagnetic induction. This electricity charges the battery and powers systems like lights, infotainment, and sensors. Without the alternator, a car's battery would drain quickly and electrical systems would fail. Battery. The battery is a rechargeable power storage unit that provides the initial electrical energy needed to start the car. Automotive batteries became common once electric starters replaced hand cranks in the early 1900s. What makes the battery distinct is its chemical process that stores electrical energy and releases it when needed. It supplies power for starting the engine and running electronics when the engine is off. The battery matters because without it, the vehicle cannot begin its operating cycle. Brake system. The brake system is the mechanism that slows down or stops the vehicle. Early cars used simple mechanical brakes, but modern systems evolved into hydraulic designs that distribute braking force evenly across all wheels. What makes the brake system unique is its ability to convert the vehicle's motion into heat through friction between brake pads and rotors, or drums. This process safely reduces speed. Brakes are critical because they directly affect vehicle safety and driver control. Suspension. The suspension is the network of springs, dampers, and linkages that connects the car's body to its wheels. It developed as roads improved and vehicles began traveling faster, requiring better ride comfort and stability. What makes suspension different is its ability to absorb bumps and maintain tire contact with the road surface. This balancing act keeps the car stable while protecting passengers from harsh vibrations. Suspension matters because it greatly influences comfort, handling, and safety. Steering system. The steering system allows the driver to control the direction of the vehicle. Early automobiles used very simple mechanical steering mechanisms adapted from horse-drawn carriages. What makes the steering system unique is the way it translates the driver's rotation of the steering wheel into angled movement of the front wheels. Modern versions often include hydraulic or electric power assistance. Steering is vital because precise directional control determines how safely and confidently a car can be driven. Fuel pump. The fuel pump is the device that moves fuel from the tank to the engine. It became necessary when fuel tanks were placed farther away from engines and gravity alone could not reliably deliver fuel. What makes the fuel pump different is its ability to maintain consistent pressure in the fuel system, ensuring the correct amount of fuel reaches the engine. This steady flow supports efficient combustion. The fuel pump matters because an engine cannot run without a reliable fuel supply. Exhaust system. The exhaust system is the pathway that carries gases produced by the engine away from the vehicle. It developed as engineers needed a way to safely remove combustion byproducts and reduce noise. What makes the exhaust system unique is its combination of pipes, catalytic converters, and mufflers that guide, filter, and quiet the exhaust flow. This system reduces harmful emissions and engine noise. It matters because it protects passengers from toxic gases while helping vehicles meet environmental regulations. Air filter. The air filter is a protective component that cleans the air entering the engine. It became standard as engines grew more sensitive to dust and debris. What makes the air filter different is its layered material designed to trap tiny particles while still allowing sufficient airflow. Clean air improves combustion and protects internal engine components from where the air filter matters, because it helps maintain engine efficiency and prolongs engine life. Spark plug. The spark plug is the small device that ignites the air-fuel mixture inside an engine cylinder. Its origins date back to early gasoline engines that required a reliable way to trigger combustion at the correct moment. What makes the spark plug unique is its ability to produce a precisely timed electrical spark across a tiny gap. This spark initiates the combustion that drives the piston downward. Spark plugs matter because without that ignition, the engine cannot generate power.